Every year, billions of tires are discarded across the planet. They look harmless, just black rubber circles. Quiet, motionless, but stack them high enough, and they become something else. A fire hazard that can burn for weeks. Thick black smoke swallowing highways for miles. Toxic clouds shutting down entire cities. I've seen it with my own eyes. A single spark, one careless mistake, and suddenly the sky turns black. That's when people realize old tires are not just waste. They are environmental time bombs that now imagine a different scene. Truck after truck arriving at a recycling facility. Thousands of discarded tires collected from repair shops, transport fleets, landfills. Each truckload looks ordinary, nothing dramatic, just rubber, until you unload them. The receiving floor fills rapidly. Tires roll, bounce, pile up against one another. From above, the entire yard looks like a sea of black circles stretching in every direction. An ocean of potential risk or opportunity. Because here's the truth most people never think about. Once those tires are stacked together, the danger multiplies. Heat builds internally. Air pockets trap oxygen. If ignition happens, suppression becomes nearly impossible. These piles can burn for weeks, even months. Firefighters don't extinguish them easily. They contain them, they wait, they endure. That's the reality of unmanaged tire waste. But inside this facility, the story changes. Once those trucks cross the gate, the tires are no longer garbage. They become feedstock, inventory, industrial input. And what happens in the next few hours determines everything. Will they sit and decay? Or will they be broken down, separated, transformed into something valuable? This is the moment where risk turns into engineering, where a mountain of waste becomes a controlled system, where billions of discarded tires begin their second life. Once the piles are organized, the real work begins. Massive grapples lift entire clusters of tires and drop them onto a conveyor system. Built to handle relentless volume, the air smells faintly of rubber and steel. The noise is constant, controlled, purposeful. Ahead stands the impact crusher. This machine doesn't hesitate. It doesn't struggle, it tears. Rotating shafts armed with hardened blades grab each tire and pull it inward. The rubber resists for a split second, then gives way. Thick sidewalls split apart. Steel belts snap under pressure. In seconds, a perfectly engineered tire is reduced to rough fragments. This is not chaos. It's precision violence. The crushing process must be exact. Too aggressive, and valuable material is damaged. Too weak, and the steel remains tangled inside the rubber. Sensors monitor torque. Operators watch load levels carefully, because efficiency here determines everything downstream. As the shredding continues, magnets move into position. Powerful separators pull steel wire from the shredded rubber stream. You can actually see it happen. Thin strands of reinforced metal lifted cleanly away from the black fragments. 10 to 15% of every ton will be steel, clean, recyclable, ready to be melted and reborn in another industry. The remaining material moves forward, smaller, more uniform. The crushing phase is complete. What once looked like whole tires is now reduced to manageable pieces prepared for thermal transformation. And this is where the numbers start to matter. From 1 ton of waste tires, we typically recover multiple streams of value. 40 to 50% will eventually become pyrolysis oil. About 30 to 35% will turn into recycled carbon black. A small portion becomes syngas that powers the system itself. But none of that happens without this stage. Because before you can transform rubber into energy, you must first break it down. After crushing, the shredded rubber moves toward the heart of the facility, the reactor. This is where most people imagine flames and explosions. They expect chaos, but what happens here is far more controlled and far more powerful. The chamber is sealed tight. No oxygen, that's critical, because with oxygen, rubber burns. Without it, rubber transforms. The temperature climbs steadily -400 degrees Celsius, 500, sometimes approaching 600. Inside that steel vessel, the long molecular chains that once made the tire strong and flexible begin to break apart. Not violently, methodically. This process is called pyrolysis. Instead of open fire, we apply heat in a controlled, oxygen-free environment. The rubber doesn't ignite, it decomposes. Hydrocarbon vapors rise from the shredded material and travel through condensation systems, where they cool and turn into liquid, dark, thick, energy-dense. This is pyrolysis oil. From 1 ton of tires, roughly 40 to 50% becomes this oil. It can be refined, blended, or used in industrial heating systems. What once rolled across highways now fuels furnaces and heavy industry. But that's not the only output. As gas is separate, a portion remains non-condensable. That gas, syngas, is redirected back into the system. It helps power the reactor itself. A small percentage, but crucial. It reduces external fuel demand and improves overall efficiency. Inside the reactor, solid material remains, black, powder-like residue. This will become recycled carbon black. Around 30 to 35% of each ton ends here. No flames, no towering infernos, just heat, pressure, and chemistry working in disciplined silence. This is not destruction, it's controlled reinvention. When the reactor cycle ends, the silence feels heavy. The transformation has already happened. What remains now is separation and precision. The solid residue left behind is not waste. It is recycled carbon black, fine, dark, lightweight. At first glance, it looks like simple soot, but in industrial terms, it holds serious value. Roughly 30 to 35% of every ton of waste tires ends here. This recovered carbon can be upgraded, milled, refined, and sold back into manufacturing. It strengthens rubber products. It reinforces plastics. It becomes pigment, filler, reinforcement material. What once gave strength to a tire can now strengthen something entirely new. Meanwhile, steel recovered earlier in the crushing stage is compacted and prepared for shipment. 10 to 15% of each ton becomes clean scrap metal. That steel will be melted, reformed, and returned to supply chains far removed from the tire industry. Construction beams, automotive parts, industrial components, nothing is random. Each stream is measured. We calculate yield percentages constantly. Oil output, carbon recovery rate, steel purity, gas reuse efficiency. Because in this business, value is not estimated, it is engineered. What started as a mountain of discarded rubber is now divided into defined commodities: oil, carbon, black or steel, energy, gas. The chaotic pile of tires in the receiving yard has been reduced to organized industrial outputs. And this is the moment when perception changes, because what most people saw as waste was actually inventory waiting to be unlocked. Now step back for a moment. Imagine if this facility didn't exist. Imagine those truckloads never arrived here. No crushers, no reactors, no separation systems, just piles, growing higher, spreading wider. Because here's the uncomfortable truth. Billions of tires are discarded globally every year. If they are not processed, they don't simply disappear. They accumulate. And when tire piles grow large enough, they become unstable. Heat builds inside them. Air circulates between the gaps. All it takes is one ignition source, lightning, friction, arson, and the result is catastrophic. Tire fires are not ordinary fires. They burn hotter, longer, harder to extinguish. Thick black smoke can clog highways for miles. Oil runoff contaminates soil and water. Cleanup can take months, sometimes years. That is the cost of inaction. This is why every stage inside this plant matters. The crushing, the separation, the controlled thermal process, the recovery of oil, carbon black, steel, and syngas. 40 to 50% becomes pyrolysis oil. Usable energy, 30 to 35% becomes recycled carbon black. Industrial material, 10 to 15% becomes steel, returned to metal supply chains. A small portion becomes syngas, helping power the system itself. When managed correctly, nearly the entire tire is transformed. When ignored, nearly the entire tire becomes a liability. That difference between hazard and resource defines this industry, and the responsibility is enormous. Because the world is not producing fewer tires, it is producing more. Stand at the end of the processing line and look back at where this journey began. A truckload of discarded tires, a receiving floor covered in black circles, a potential environmental disaster waiting for a spark. Now look at what remains. Measured tanks of pyrolysis oil, 40 to 50% of what once rolled across highways. Stored energy, ready to fuel heavy industry. Refined recycled carbon black, 30 to 35%. Powder that will reinforce new rubber, strengthen plastics. Return to manufacturing lines instead of sitting in landfills. Compressed bundles of steel, 10 to 15%. Clean metal moving back into global supply chains. And a controlled stream of syngas quietly feeding energy back into the system itself. Nearly every component accounted for. That is the difference engineering makes, because the tire itself was never the problem. The problem was what happened after it wore out. Left unmanaged, tires become environmental time bombs, capable of choking highways with smoke, contaminating land, draining public resources. Managed correctly, they become part of a circular industrial engine. This is what people rarely see. They see the tire when it's new. They feel it gripping the road. They replace it when it's worn. But they don't see this facility. They don't see the crushers reducing it to fragments. They don't see the reactor breaking it down at 500 degrees without flame. They don't see the separation systems recovering oil, carbon, steel, and gas with calculated precision. And maybe that's how it should be. Because true industrial progress doesn't need applause. It needs reliability. Billions of tires will continue to reach end of life every year. That will not stop. The only question is whether we treat them as waste or as resource. Inside facilities like this, the answer is clear. We don't see mountains of discarded rubber. We see stored energy. We see raw materials. We see opportunity waiting to be engineered. And as long as the trucks keep arriving, the system keeps running.